Welcome to this explainer on the Palm Oil Frond, from green waste to a hidden gold mine. Today we're going on a seriously high-stakes journey. We're going to completely flip how we look at agriculture and sustainability. We're taking this massive, thorny burden and turning it into an absolute triumph of the circular economy. Let's see how a seemingly useless byproduct actually holds vast, untapped potential. Millions. Right off the bat, to really grasp the gravity of this situation, you have to understand the sheer massive scale of the problem we're dealing with. Think about it. If you fly a drone over Malaysia, you're going to see these vast, endlessly green palm oil estates. Absolutely beautiful, right? But within those estates, millions of tons of green waste are generated every single year. It's literally an unfathomable amount of physical plant matter just sitting there. Okay, let's dive into this. What exactly is generating all of this waste? Well, it's the OPF, the oil palm frond. These are the massive, heavy leaf structures of the palm tree. And let me tell you, these things are incredibly dense and covered in sharp thorns. Now, because the actual valuable product, the palm fruit, grows right up near the trunk, estate workers have to prune these heavy fronds on a routine, weekly basis just to get to the harvest. So you multiply one weekly pruning by millions of trees, and boom, you immediately see how this mountain of waste piles up. Now, naturally, you might look at a giant pile of these heavy, thorny leaves and think, man, what a nightmare to clean up. But here is where we need to shift our perspective, from just waste management to actual resource discovery. See, on the outside, a freshly cut frond is exactly what it looks like: tough, woody, fibrous material built to survive the elements. But if you look inside, hidden behind that tough armor is a rich biological storehouse packed with inner moisture. And this brilliantly illustrates exactly what makes that inner moisture so special. We are definitely not just looking at dead plant matter here. A molecular breakdown of the inner frond reveals incredibly high levels of cellulose, hemicellulose, and lignin. And that high cellulose content, that's exactly what makes it a powerful, super efficient biofuel alternative. Add in the fact that the whole thing is basically swimming in nutrient-dense natural sugars, and suddenly we're looking at a highly valuable raw biological resource.
But we've got an immediate, urgent problem. If we don't extract that hidden value, we're left with a dangerous situation on the ground. It's a full-blown field crisis. See, when workers chop down these heavy fronds and just leave them piled up in the rows of the plantation, that tough, woody exterior causes them to take a really long time to decompose. They just sit there, drying out, decaying slowly, and physically blocking the pathways workers need to navigate the estate. But honestly, way more alarming than a blocked path is what starts moving into those rotting piles. These decaying mounds create the absolute ultimate breeding ground for pests.
In fact, agricultural data calls these piles the ultimate breeding ground for devastating pests, specifically the rhinoceros beetle, which destroys young crops. Just picture a tiny, heavily armored beetle crawling all over the rotting wood of a discarded frond. It completely thrives in that decaying matter. And from that safe little haven, the beetle launches attacks on the young, vulnerable palm crops. So leaving these fronds to rot doesn't just make the farm look messy, it actively, literally, endangers the future survival and the yield of the entire estate. So the crucial point here is that we absolutely have to intervene. But the amazing part is, when we do step in, we realize this massive waste problem is actually a hidden gold mine. This is where our story shifts from this urgent, ominous crisis into something really exciting, a story of energetic hope and incredible innovation. Let's move to the actual process and see how this builds, because the exact steps to unlock this gold mine are absolutely fascinating. It's really fast-paced. Step 1, obviously, is pruning that heavy frond from the tree so we can get to the fruit. But instead of just dropping it on the ground for those rhinoceros beetles, we jump right to step 2. We feed these massive leaves through incredible machines that rapidly shred those tough fibers down into a fine, manageable powder. Then, step 3, we process that rich, sugar-dense powder into high-value products. We are talking high-energy biomass pellets for fuel and incredibly nutritious feed for cattle and other livestock. Think about that for a second. We literally just turned a pest-breeding hazard into fuel and food. Now, for a truly zero-waste circular economy, what's really fascinating is what this means for the big picture. Processing these rich fibers completely neutralizes the OPF field crisis. But beyond just cleaning up a farm, it's the exact blueprint we need for a truly sustainable, zero-waste agricultural system in Malaysia. The very thing that was choking the estate and breeding pests is now powering industries and feeding livestock. Nothing is wasted. The loop is entirely closed. How cool is that? Which brings us to a final, incredibly important question to leave you with. How can unlocking the hidden value in our waste streams become the ultimate key to a global circular economy? The story of the Malaysian oil palm frond proves that what looks like a heavy, thorny burden on the outside can actually be a rich, life-sustaining resource on the inside. It all comes down to how we process it. I want you to look around your own world and rethink how you view waste. The solutions to some of our biggest global challenges might just be sitting in a pile of discarded leaves waiting to be utilized. Thank you so much for joining this explainer. I really hope it sparked your curiosity to rethink the resources around you. Catch you on the next one.